each and everything that we do has a lot of storage element in there. Whether you like it or not, there's a lot of storage in every device that you handle on a day-to-day basis, on a minute-to-minute basis. And that happens over the air, through Wi-Fi or connectivity or through Zigbee, a lot of standards that come into play. And then, because each and every device is battery operated, and the batteries last for a finite amount of time. It could be a matter of hours or days, maybe months if you're lucky, or year if you're extremely lucky and if the extremely good process. And that's what we're aiming to. And everything has to be integrated, and GlobalFoundries is now going in a route where they work with customers and provide them very, very fine-tuned solutions which are end-to-end. And we'll talk about end-to-end solutions when we look at all different kinds of non-volatile memories, different kinds of connectivity options, different kinds of power and low leakage and low power options, everything integrated on a turnkey basis with different kinds of packaging options. When you put all these in one small device, the package obviously makes a lot of difference. When you work with a non-volatile memory, you cannot just work with a non-volatile memory and not be able to test it. So GlobalFoundries is working with all the ecosystem providers and all the IP providers to provide an end-to-end solution where you don't have to look for other options to really be able to put together. So GlobalFoundries can provide you from all the way from a single point when you start designing a device to the end to be able to deliver a device, totally tested packaged, or a known good device, or wafer. In whatever form you wish to basically work with the round things, cut them into small square blocks or rectangular blocks, put them in your design, make them work. So let me take you to see how each and everything actually comes together. We talk about smart analog. Smart analog basically has a lot to do with how the devices work. When do they turn on? When do they turn off? What is the leakage? Or sub-picoamp leakage. We're talking about standby leakages. We're talking about dynamic power. And all these basically have to have an interplay in power management based on the devices they are put in. And as you can see, everything is not about 0 to 5 volts. It actually goes up to, let's say, 100 or 700 volts when you look at an LED, the lighting aspects, for instance. And everything has to do with power management and different kinds of devices. And when you have so many options and devices to integrate, you cannot keep rebuilding each and every device, each and every time you want to make your design. So essentially, there is something we do like a baseline process, and then we start working with our customers in addition to what we have done or on top of what we have already provided to tune it further. So that kind of brings us back to a modular platform with all these options, with a baseline process, with a module for connectivity, basically an RF module, a non-volatile memory module, a BCD module for power management, and then if you need something custom, we kind of tune it and how to achieve the best performance. How do you achieve the best power? How do you achieve the best area? So the power, performance, and area you kind of are able to achieve by having a baseline process and adding modules as you use them, because each and every module adds to your cost. So basically, you use it, you pay for it. If you don't use it, you don't pay for it. So it's a pay-per-use kind of a concept here, because it's a modular platform. And all these are that I'm talking about, we'll see as we progress, which my colleague also will touch upon, comes together in the manufacturing organizations and the facilities that we support, all the way from a 180 nanometer to a 10 nanometer kind of process geometry. So the processes that we're working with are very mature. Let's say in 180 nanometer to 40 nanometer, we have been doing a lot of work on these processes for quite some time. So we understand them very well. We have manufactured millions of wafers. So the inherent robustness of the process, the predictability, how deterministic it is, it's all very well documented. And then the modularity basically plays in, where you use what you use, and where you don't need something, you basically remove, so you don't really add to your number of mask layers. So that way, everything that we do in the smart analog is basically putting together low leakage processes, low power processes, for extremely high efficiencies, be it wireless charging, or be it power management, be it LED lighting. So all these devices basically depend on what kind of performance you're looking. Are you looking for an analog performance, or are you looking for a switching performance? So basically, where are you going to operate on the IV curve? Is it saturation, or is it a linear region? And everything basically is offered in terms of these devices that we talked about just now. And the next one is, we call it an Internet of Things. Essentially, the Internet of Things is nothing but a connected world that we have been seeing for a long time. But with all these mega trends coming to play, like the Wi-Fi, like the cloud and security, we kind of look at all these converging to a solution which we can very quickly put together in a block diagram. What do you need in an IoT device? A controller, for instance, a storage element, something that can go back and forth between your smart device for data analytics, and a sensor, essentially. If you look at any of the devices that you wear, like a Fitbit, what does it do? It has a sensor, like an accelerometer or a gyroscope, essentially that kind of measures data in an analog format, and then it stores for more analytics, and then it sends it to your iPhone or iWatch, something that you can use for maybe to monitor your progress. So essentially, that has to do with power management also, because the watch has to last for a long time. The fitness device has to last for a longer time on a battery. And that, when you look at how that translates into the IP and the processes that we provide, we have been, so you can always break them into different kinds of wafer size, aspect ratios, right? Like the 200 millimeter or a 300 millimeter. That kind of goes all the way from a 180 nanometer to a 40 nanometer solution here. But we don't just stop there. We'll go further, and that's what my colleague is going to talk about. How do we offer something to a customer all the way from a 180 nanometer to, let's say, 10 nanometer or 7 nanometers? So once you engage, you can build your roadmaps. You can build your product plans. You don't have to look away anywhere else. When you start from 180, you have the roadmap to a 130, 55, 40, and then you go to 28 nanometers, 20 nanometers, 10 nanometers, all the way. And all the IP that we play, we kind of have a roadmap for that. So another very interesting aspect is when you have a sensor can be a monolithic device. Or as we achieve increased levels of integration, the sensor we should be able to integrate the sensor with the CMOS. So essentially, it brings down the form factor. So if you go back and look at the kind of devices, we started the MP3 players, for instance. We started with something that had a tape and then a solid-state device for memory and storage. And now they're so sleek, they're so small, because devices are being integrated. Functionality is being integrated. So you have more packed into a smaller area. So when you have the ability to integrate the MEMS into a CMOS, that's the value proposition that we actually bring. The GlobalFoundries manufacturing facilities have the capability to be able to integrate a CMOS and a MEMS into one monolithic die. Similarly, when we move from 180 all the way to 40, we have the capability to offer you devices, high voltage devices, all the way from 180 nanometer to 40 nanometer. So you have up to 30 volts on all the nodes. We have up to 700 volts on 180 nanometer. The 700 volts basically can be used for AC/DC or LED lighting kind of applications. We have embedded flash, storage elements on all the nodes. So essentially, it kind of goes from 180 to 130 to 55 to 40, and we keep hand-holding you. And not just 40. I'm talking about 40 because I start going old at 40, and my colleague starts going young at 40 because he starts going from 40 to 28 to 20 to 10 to 7. So I am the older guy, and he kind of goes young day by day. Now, if you look at each of these nodes, all these are very mainstream nodes. All these are mature nodes. That's why to tweak these processes to operate at, let's say, threshold or sub-threshold, to offer you the leakages and the power, we can definitely look at these nodes to do more of innovation, to do more of disruptive technologies. Because the mainstream nodes are all about more than more. And this term has been extensively used, the more than more that we call. Because if you look at how many transistors can be packed, it's not linear anymore. It has to stop somewhere. So the innovation has to happen. It has to start somewhere. And this integration is all about what we're talking about. Now, there's a lot of buzz in the automotive. We've seen cars that started maybe, I grew up in a place where the cars were huge, very, very functional cars. So if you get into an accident, the car never gets hurt. The car is intact. From then, we have light cars, which are now we have more functionality packed into everything that we do when we drive a car. The car is so intelligent, it can drive by itself. How does it happen? Because there's so much of controllers built in there. And GlobalFoundries basically has been in this business for a long time. Our processes have been certified for the ISO TS16949, and we support our customers to achieve their AEC Q100s by supporting them with all the FMEAs, PFMEAs, DFMEAs, and helping them to put their PPAPs together based on their AEC Q100 specs. So, and we are also a technical committee member, so we are a trusted partner. We work with all the semiconductor vendors and do the modules with collaboration with partners, and we kind of try to support them all the way. So if you look at the value chain of the automotive, it's a little different. The standardization is different. It is more stringent in the temperatures and the grades, 0 through 1, 0 through 4. So 0 is being the stringent, most stringent for junction temperatures and ambient up to 175 degrees centigrade. So GlobalFoundries has basically supported customers in automotive areas for a long time. And we have our processes, the IP, the entire ecosystem, including the EDA support, the testing support, everything that basically handholds the customer all the way till the product is shipped, not just the wafers. So what I would like to do now is to show you how we go from a 40 nanometer and start getting younger. So I would like to call Dr. Shubhankar Basu to show us how can we get younger from 48 nanometers all the way to 10.
Okay. Thank you, Shri. Am I audible? All right. Thank you, Shri. I think you missed one bullet. Okay. So yeah, what you heard right now from Shri is, GlobalFoundries tuned solutions for all the mature node applications, which ranges from smart analog, automotive, and IoT, which is the new application space. What I'm going to take you through right now, and I know that this slide has a transition problem. It keeps going there. But I want to show you guys first, in terms of the early adoption of any leading edge technology, who are the early adopters and what are the application needs for these segments, right? So if you look at this chart, going from left to right, you see ultra low power, and pardon me for this annoyance, but the ultra low power kind of requirements on the IoT devices, mobile computing, and to the consumer segment where you have laptops, netbooks, notebooks, digital TV, and gaming kind of application. And then you can go through all the way up to the very high speed networking segment, which has requirement for performances well above 3 gigahertz range, and this is primarily driven by the logic enhancement in the leading edge technology space. If you look at oops, this time I preemptively did that. If you look at the performance envelope, how it is pushing down, you are going down all the way into single-digit milliwatts, essentially to extend the battery life of operation, right, and to cut down on the standby leakage power. And also, by the way, to meet these different application needs, it's not a one-size-fits-all solution, neither in terms of the power performance targets of the technology offering, as well as the cost. It cannot be that a single cost solution can fit into this wide range of applications that are catered to by the leading edge technologies. And it's a very well true for the matured node solutions as well. It's very true for the leading edge applications too. So in order to look at some of these, if you deep dive into some of these application space, look at high performance computing first. As I mentioned, that the performance ranges we are talking about is upward of 3 gigahertz range almost in today's world in the early adoption stage. What do these high performance applications need? They need the best in class performance per dollar spent, and everybody wants to keep the cost low, right? There's no rocket science there. So best in class performance, and also best performance per wattage. So meaning that, even though we say that emphasis is on one aspect, compared to the other, higher or lower, but they need both. So you want the best-in-class performance at the lowest power consumption point and at the lowest cost point. And not to mention, one thing is very common. It was common, the matured nodes is more prevalent today with the reduced time to market requirement and the faster speed of coming up with a device and launching it in the market. You have to have a very integrated solution readiness. So you have to have a solution that works with the operating system, software, application, and the infrastructure. So all of these together are the needs for a high-performance computing side. GlobalFoundries, again, on the tuned solution offering standpoint, we had been offering 28 nanometer. Again, it's by the way, I'm just taking it away from the 40 nanometer node. That's what we call leading edge solution. 28 high performance plus technology we had been offering since 2012. Already shipped millions of wafers in our from our Fab 1 in in Dresden, Germany. 14 LPP is real in 2015. It's a FinFET technology, 3D gate structure, providing the best-in-class performance boost over its planar equivalent because of the folded gate architecture, right? So 14 LPP is a technology fully qualifying and maturing for the high-performance needs for this class of the network processors or the compute connect storage segment needs. And then following through, we will have the second generation of technology in 10 nanometer and so on. So if we look at the offering, though, technology alone cannot solve the problem. If you take the entire design ecosystem, design and manufacturing ecosystem, has to be a tight collaboration. Number one. Number two is that the readiness of the enablement side is absolutely critical for our customers to see first-time silicon success, as well as removing any kind of design risk pins, which are very expensive in these nodes because the technology is complicated. So in order to do that, we understand the high-speed IP requirements for this segment. We understand the high-speed memory requirements. We understand the high-performance libraries, the need for a high-performance stack. We talk about passive devices which can meet this extra high frequency ranges. We also talk about integration and packaging technologies that meet those integration needs, like a 2.5D or a 3D packaging or a TSV enablement. And last but not the least is digital design flows, or the analog and mixed signal design flows need to be completely ready for our ecosystem to, for our customers to adopt these solutions readily in their design cycle. And that's what we provide from GlobalFoundries. Just to highlight on these key points, on 28 nanometer technology is a mature technology in our fab in Dresden. We have shipped over 1 million wafers, on the high-k metal gate 28 nanometer technology. 14 LPP is our FinFET platform. That is, first generation is already qualified. Second generation getting qualified in 2015. Full readiness, volume ramp, and product tape outs happening as we speak in our fab in Malta, New York. Okay, now look at the other end of the spectrum, which is the mobility, consumer, and IoT application. Typically, when we think about this application, first thing that comes to your mind is that there is a need for lower and lower cost for these technology offerings. There is a need for lower and lower power points for these technologies. Two things that come immediately to your mind. Of course, again, as I said in the high performance side, when you are coming down, lowering the power doesn't mean that you are going to cut down on the performance, absolutely to a lowest level. So they need an adequate level of performance, optimal performance, but at a lowest power point and at a lower cost. So that's what these applications need. They need a lowest watts per performance for a longer battery life, handheld kind of application, highest performance at the lowest dollar point, and again, integrated solution that is well-tuned, fine-tuned with the operating system, application software infrastructure. On the technology side, GlobalFoundries, again, had been offering a 28 nanometer super low power variation to meet these low performance, low power market needs. We have also been offering a polysilicon based, even lower cost 28 nanometer technology. These are fully qualified in our fab. And recently we announced the launch of our SLP RF technology. And this is to meet the needs for those super high performance RF devices to go along with this mobility application, which can operate over multiple ranges. You talk about 2G, 3G, 4G, LTE, etc. RF is absolutely critical, and that is now fully available from our foundry. Together with that, enablement again becomes a key. So we have a lower power operation need from the technology standpoint. We have high-speed interface IPs. We have low power power consumption IPs, ultra-high density IPs, standard memories as well as libraries. We have all the standard IPs that are required to meet the needs of this early generation of the adopters, low-cost stack, and as well as innovative packaging technologies, 3D technologies, as well as wafer-level fan-out kind of packaging technology. So, in essence, the launch of 28 SLP RF was very critical for us. We did that recently, and it meets the ultra-high frequency range of all these radio kind of applications for mobile RF technology needs. 14 LPP, as I mentioned, as a FinFET technology, it's not only higher performance, it also extremely low power, right, because of the architecture of the device. So that's a sweet characteristic of a FinFET device, and that's going to be ready in Fab 8, completely volume ramped in 2015, and it suits very well with our IPs and the design tool readiness to to design products for our mobility and low-end applications. And also, we are also in the process of developing advanced FDSOI technology. Now, FDSOI as a device also offers certain great advantages over even a planar variant, or it's a planar bulk variant, as well as the FinFET technologies. So it used efficiently to, with the forward and back bias, body bias condition, the device can be operated at extremely low voltage condition, as well as to drive a performance up to not match or compare it to a FinFET kind of operation. Depends on the IoT need. We see that FDSOI is going to be widely used for IoT kind of applications. All right. So besides the technology and enablement, as I mentioned, we also, as Shri just pointed out, that as a foundry, we tend to take away the headache from our customers to reach out to multiple supply chain partners, whether it is for the wafer level fabrication or the packaging and so on. So we do all our packaging developments. You can talk about TSV, 3D, 2.5D, wafer level fan out, qualification of large die or small die packaging, and we work with our OSAT partners in a collaborative device manufacturing model, so that the customers can have a drop ship kind of a engagement with us. They can just drop the chip, and it can go all the way to provide an extremely efficient turnkey service offering back to our customers, so that it takes away the the decision making or the headache from our customers. So one thing I cannot emphasize more. This is particularly applicable to the leading edge technologies as we are seeing today. It's also applicable across nodes, I guess, is the innovation that needs to happen collaboratively between EDA, IPs, and the foundries. It is not one side of the business doing, developing something one step ahead of the other. It cannot go that way. We worked hand in hand with our partners here to build solutions to deal with the complexities of the the next generation, to make it as transparent as possible to our end users, the designers, and to provide us on-time readiness for the platform, so that customers can see first-time silicon first-time silicon success, and have a correct-to-construction design. Okay, so with that, I think I'll end the talk. Actually, just one quick point. GlobalFoundries, I'm pretty sure that all of you have heard the name. It is a truly global foundry with operations spread across 3 continents. We have our fab location in Malta, New York. We have in Dresden, Germany, and in Singapore. And it's a large-sized startup, if you can, spun off from AMD in 2009. We employ more than 13,000 employees and over 160+ customers. So we are not a new kid in the block, developing nodes all the way from quarter micron technology to the most leading edge, cutting edge technologies. 14 nanometer in 2015 is for real. Check us out, and check us out on our website for the different offering. Okay, thank you so much, and we can take some questions.